2007, and she did research there on making small molecules that target serotonin receptors. And now she's currently a third-year graduate student at the University of Michigan, where she's working with Dr. John Wolf on palladium-catalyzed reactions. So help me welcome Danny.
Thank you very much for the introduction, and I'm glad to hear I had a fun time here through my school. And today I'm going to be giving you an insider story about chemistry through my eyes, and I'm going to interdisperse some facts about chemistry that you may not know and some opportunities that you have with the chemistry degree. So first, a little overview about chemistry. We're going to be talking about the different disciplines that you can pursue if you were to have a degree, and the type of chemistry careers that you can have with a chemistry degree. And so throughout my talks, I am an organic chemist, so I'm going to be focusing more towards organic chemistry. But if you have any questions about any other areas, feel free to ask me. I'm going to talk about my undergraduate education and the type of education that you can receive with a bachelor's in chemistry, graduate education, which is where I am now at the University of Michigan, and then lastly, postdoctoral research. And so you can see that I have research underneath. Oh no, it died. So you can see that I have research underneath undergraduate education, also graduate education, because research is a very big component in receiving an education, and it really helped me decide that I wanted to go into graduate school. So there are four major disciplines of chemistry: physical chemistry, biochemistry, organic chemistry, and also inorganic chemistry. So as I said, I am an organic chemist, so it's simple, and I'm going to be going into more of a discussion on that later. So physical chemistry, I am showing by this complicated mathematical equation. So a lot of physical chemistry has to do with math, and it uses math to, I guess, predict and to govern. Thank you very much. So physical chemistry uses lots and lots of math, and it uses math to predict and govern and decide why chemical reactions happen the way they do. And so one example would be why an electron lies in an orbital. Biochemistry, on the other hand, is the study of chemical reactions that happen in the body. So one example would be metabolism. So when you eat a candy bar or these cookies, the sugar is being broken down, you're making CO2, you're making water, you're making ATP, and so this is all studied by biochemists. And this also includes the study of enzymes, proteins, and nucleic acids, so DNA and RNA. Organic chemistry, which is near and dear to my heart, is the study of, pretty much the study of carbon. So by definition, if you look up organic chemistry, it's going to say that it's the study of carbon and its derivatives, the reactions that carbon and its derivatives undergo, and the structures of carbon, and so forth. And lastly, inorganic chemistry is everything that organic chemistry does not encompass. So anything not including carbon is studied by inorganic chemists. So these are mainly like metals. So why dedicate an entire discipline of chemistry to carbon? Well, carbon is very important because it composes 18.5% of our body mass. So through your own eyes, you should want to study this atom that comprises a lot of our body. Also, carbon is very unique in that it can only have 4 bonds to other atoms. And by doing so, you can have a property called allosteres. So allosteres are when you have 2 different materials that are completely comprised of one element, so in this case carbon, but they differ in their connectivity, and as a result, they have different physical properties. So you can take something like diamond, which we all know to be very, very hard, and you can see diamond is arranged in this tetrahedral type matrix, and this is what makes diamond so hard. It's very hard to disrupt that matrix. But on the other hand, you can take something like graphite, which is found in a pencil, and here the carbon atoms are arranged in this very linear type fashion. And so when you write with your pencil, it's very soft because you're just removing a sheet at a time. So that's kind of an interesting property of carbon. But organic chemistry to me isn't really just a study of different forms of carbon and how they can connect. It's really about how it affects me every day and how it's present in all of our lives. So the chairs that you sit on, the clothes that you wear, the food you eat, stuff you drink, all has something to do with organic chemistry. So here I'm showing a few different examples. You can take, say, polyethylene, which is number 2 plastic. And this is what holds milk. So chemists had to develop a plastic that was going to be durable enough to hold large driving force for the pharmaceutical industry in that